In this next video, we're really going to focus on this definition that I wrote down in the previous one. So A and B, matrices A and B are inverses if and only if A times B is the 3 by 3 identity and B times A is also the 3 by 3 identity. So we're not really discussing how to find that identity or anything here. We're just showing, kind of relying on that definition we developed before to show that two matrices are inverses. So let's go ahead and let's get two matrices, show that, I'll just say A and B are inverses, or they might not be, so we'll multiply them and see what we get. So show that A and B are inverses. So let's have A equal the matrix 2, 1, 5, 3. We'll start off with a 2 by 2 situation. And B equals 3, negative 1, negative 5, and then 2. And our goal here is for A times B to equal the 2 by 2 identity matrix, which was 1, 0, and then 0, 1. And also B times A should equal the 2 by 2 identity matrix. So let's go ahead and do this. Let's take A, 2, 1, 5, 3. Let's multiply it by B, 3, negative 1, negative 5, 2, and see what we end up with. Now, the previous lesson in section 8.2, we talked about matrix multiplication. So let's go ahead and let's maybe do this first spot kind of slowly. It's going to be 2 times 3 plus 1 times negative 5. We're, remember, kind of mashing these together. 2 times 3 and then 1 times negative 5. So we'll get 1. So far, so good. That is what we want. The next one's going to be negative 2 plus 2, which will give me 0. That's also good. Next one is going to be 15 minus 15, which is also going to give me 0. And then 5 times negative 1 is negative 5, plus 3 times 2 is 6. So that's 1. So that actually does check out. That works. That is the 2 by 2 identity matrix. Going back the other way, you could go ahead and check this. 6 minus 5 is 1. Negative 5, 3 minus 3 is 0, etc., etc. And so it's also going to work out this way. So we do conclude in this case that B is a inverse, and we actually showed that it works. So those two are inverses of each other. This could be taken to 3 by 3 situations as well. It's going to be a little bit more work. But let's say I had 2, 0, negative 1, and then I had 3, negative 1, 1, 0, 2, negative 3. And let's have, now B is going to have some fractions in it for this to work. I worked this out beforehand to make sure that it actually was an inverse. But let's go ahead and check it anyways. So in order for this to work, it's kind of a mess due to these fourths and halves in here. Negative 3 over 2, 1, and then 1 half. Okay. So now in this case, our goal is to get the 3 by 3 identity matrix. Let's do a couple of these here. Let's see if it works. So 2, 0, you know what? That's going to take too long to write out, so let's not do it. But 8 times B. So in the first position, let's say that the answer is, let's just call it M for matrix. So for M1, 1, going back to section 8.2 to understand this notation, it's going to be 2 times negative 4, which is negative 1 half, plus 0 times whatever is 0, plus negative 1 times 3 over 2 is 3 over 2. So I get negative 0.5 plus 1.5, so that does actually equal 1, which is what I would like. For the second position, M1, 2, it's going to be, keep in mind here's what I'm doing. I'm going 2, 0, negative 1, And then the second column of B is 1/2, 3 over 2, and 1, and we're kind of mashing those together. And so I end up with 2 times 1/2 is just 1, and then I get another 0, and then minus 1, so that's 0. And we would keep doing this, 2, 0, negative 1. The first row with the third column is 1/4, 5/4, and 1/2. So I end up with 1/2 plus 0 minus 1/2, so that would also be 0. So we would continue this pattern, and we'd go through the entire thing, and at the end of the day, like I said, I have already checked this, we would end up with this matrix 1, 0, 0. Those are the ones we already found, and then we would get 0, 1, 0, 0, 0, 1, which is the 3 by 3 identity matrix. So that is correct, and we would end there. Same with B times A. We should end up with the 3 by 3 identity matrix. So we have indeed verified that B is A inverse in this case. All right, so this video is really just intended to kind of illustrate that definition I ended with in the last video. Two matrices are inverses, going back to my highlighted point up here, if you multiply them and you get the correct n by n identity matrix.